Hello, my name is David Breitgand. I work for IBM Research in Haifa. Today I'm going to present a joint work with my colleagues from IBM. This work was partially funded by the EU project 5GZorro. Let me first give you the outline of the talk. I will start with some background, what's cloud-native transformation in the telecommunication industry and what does it mean for MANO. Then I will proceed to the main question that we explored in this paper. Do we really need other NFV MANO than Kubernetes itself? There is an assumption, some people call it hubris assumption, alluding to hubris, that we can manage everything with Kubernetes, and we wanted to test it. There is a problem associated with this approach, how to treat legacy applications that have dependencies and require properties propagation. Kubernetes is not built for that, but this is very important for traditional network function virtualization. We will present our solution, which we nickname Varuna, and then I will conclude with some conclusions. So, cloud-native transformation is not about cloud. Cloud-native computing is a set of technologies that help developing and operating scalable and portable applications as containerized microservices that are dynamically orchestrated by an elastic self-managing platform. And of course, cloud-native transformation is a journey. So these applications can take advantages of a cloud computing model, but they are basically separate. A cloud-native model is separate from the concept of cloud computing. Containers are an ideal technology for portability. Containers are an ideal technology for microservices. Containers are an ideal technology for edge use cases. Containers alone, however, are not enough for the cloud-native vision. So, cloud-native transformation is not only about containerization. In fact, cloud-native includes many features. Some people list as many as 10 features. I will not go over all of them, so there are many pillars to the cloud-native vision. Today we will focus on one pillar, which is orchestration. A de facto standard orchestration platform for cloud-native computing is Kubernetes. Kubernetes is based on the concepts of resources, controllers, and model-driven declarative management. Central concepts of relevance for this work are custom resource definitions, CRD, custom resources, CR, controllers, and operators. Operator is a powerful design pattern which is native to Kubernetes. Basically, an operator is a controller and a CRD. So a developer creates a CRD, which is a schema, a YAML schema, a document, applies it to the Kubernetes cluster. The schema gets into the database, and then instances of this schema can be created. This is called custom resources, shown here in green. And then controller that watches this custom resource gets notifications from the API server of Kubernetes. And each time an event of interest happens with the resource, controller executes some reconciliation logic that brings the observed state of the resource to the desired state as it's stipulated in the CR definition. Now let's talk a little bit about the other part of the equation, the second part of the equation about MANO. Network Function Virtualization, Management and Orchestration is an architectural framework for managing and orchestrating virtualized network functions. Network services are composed of network functions, and also it orchestrates and manages other components, other software components, actually also physical components. Virtual network functions comprise multiple virtual deployment units, VDU. Virtual network functions are traditionally based on virtual machines. CNFs, or container network functions, sometimes called also cloud-native network functions, are based on containers. And there is a new concept, recent concept, KNF, which are Kubernetes-based network functions. So cloud-native MANO today is an application, a cloud-native application, which is deployed on Kubernetes. So in itself, the leading MANO platforms such as OSM, ONAP, they are cloud native, the platforms themselves, the MANO platforms. However, what they do, they contain all the smarteners, and basically they tell Kubernetes how to orchestrate resources inside Kubernetes and treat Kubernetes as some dumb network function virtualization infrastructure that should be told everything on how to orchestrate services, resources, CNFs, KNFs, and so on. So main question explored in this work is, can we just use Kubernetes as MANO? It was actually suggested also by us as co-authors of this paper as a potential approach in this paper from web scale to telco, the cloud native journey. So in this new vision, potential vision, there is no separate MANO engine. It's actually the Kubernetes who orchestrates the network services. It's more simple, it's more aligned with the Kubernetes native infrastructure vision of the cloud native computing foundation. So first thing to ask is whether we have enough expressiveness in Kubernetes to actually mimic all the functionality of MANO. We claim that yes, you can basically draw analogies between onboarding, instantiation, scaling, configuration management, upgrade, fault tolerance, and termination that you typically find in your MANO solution. You can find analogies, very clear analogies for that in Kubernetes itself. There are some problems as well, so not so fast. So what are the problems? Kubernetes has gaps. Before we can apply it as MANO, we need to fill them. In this work, we identify and deal with two of such gaps, dynamic property propagation and composition. These features are very important to the traditional network function virtualization, but most concepts in the traditional network function virtualization predate the cloud-native era and are not handled out of the box by Kubernetes. So let's take a look at the VNF-based network services structures. There are many VNFs. They are combined into some topology. And then some VNFs can be bundled together to form packages, or I call them assemblies here. And then these assemblies can be reused in other compositions. And then these other compositions can itself be composed. So it's a nesting concept, and then these nested compositions can be included with other compositions and so on. And so we end up with something like this. And then we need, for example, to support functionality like scaling of these bundles, of these assemblies. But out of the box, Kubernetes would not support that because it only knows how to support pods scaling, pods autoscaling, not application autoscaling. So that's one problem. And the second problem is because of this nested composition and intricate dependencies between virtual network functions, we have the property propagation problems when one function depends on the properties defined in another functions, and so some property values cannot be known at the development time but only at the deployment time dynamically, and this dynamic property propagation should be handled somehow. So our approach is represented in this figure. I will very briefly walk you through this, but it's not my goal to actually tell you everything, and I hope I will tease you enough that you can read you will be interested to read the paper itself. So basically in our approach, we rely on the concept of the operator. The network services are represented by the descriptors of the network services are represented by the CRDs. CRDs are onboarded like you wouldn't onboard any other CRD on Kubernetes, and then you have operators for every VNF inside this service, and what we call generic network function orchestrator operator, GNFO, that actually mediates property propagation between different CRs corresponding to different VNFs, and we also provide an SDK that allows the developer to take one network service, one CRD, and use it inside another CRD, so to compose them. One example which is discussed in the paper in detail is voice over IP example. So here you have a GNFO operator that actually mediates property propagation from the service CRD to specific VNFs. In this case, for example, the gateway needs to get IP value instantiated, and it's only known when the correspondent component is instantiated. So GNFO actually watches the readiness of this component, and when it happens, it propagates the value of the property to the right custom resource. Now this should be contrasted with the traditional workflow way of doing things. In a traditional workflow oriented frameworks like Etsy, for example, you usually you propagate properties in the right order. In the cloud native style, you start all the components at once, and the operator mediates between these components to propagate the properties in a correct way. I will not go into the details of the composition SDK because I do not have enough time for that. You're welcome to try this technology out. References 14 and 15 actually contain references to the GitHub, so you can try that. There is a lot of related work. I only list here the related work that deal with Kubernetes drawbacks and with respect to property propagation and composition. I will not go into the details of all these different systems. Let's say that most of them are complementary. Some of them are doing similar things to what we are proposing, but basically we haven't seen yet a simple, elegant solution that is based on the fundamental primitives of Kubernetes itself, like the operator design pattern that we propose here. And we believe that parsimony is a good feature. We do not want new models. We do not want very verbose models. We do not want complex technology. So, conclusions. Kubernetes is a very smart, scalable, and robust orchestrator. It can orchestrate containers better than any other orchestrator. Using it for NFV MANO can provide truly cloud-native experience to telco. While we are not proposing to abandon the existing standards and models, we advocate for harmonization with Kubernetes. Standards are, after all, for building open ecosystems, and Kubernetes is an open ecosystem. Let's explore how to use it to its full extent. Thank you, and I will be happy to take your questions.